Okay, Anna, so you missed the lesson today. So we were doing circles and kind of keeping on the geometry unit and actually doing a lot with formulas. Okay, so we start with circles, but eventually we go into like three-dimensional shapes and stuff like that. So anyways, that's what the lesson's on. It's kind of circle geometry. Now, the start here is I just want to ask the class about what they think a circle is or what they would define a circle is. And they came up with some interesting things. You can read those things. But the actual math definition is right here. The set of all points in a plane that are the same distance from a given point called the center. Now, we talked about this idea of plane because it's like a two-dimensional space. So if you work in another dimension, you could get into this idea of a sphere versus an actual circle. So that's why you have to say it's a plane in two dimensions. Other definitions that were in there, we had radius, diameter, and circumference. So if you remember radius, you get a circle from the center to the edge of the circle, that's the radius. If you go twice that, again through the center, that's a diameter. But then circumference is this kind of distance working around the circle like so. And so in terms of problems we had to do, one is just, finding the circumference of a circle with different dimensions. So we have these two formulas to deal with. Circumference is pi times the diameter, or sometimes it's written as circumference is 2 pi times the radius. And again, because 2 times r, or 2 times the radius, is equal to 1 diameter. So in the examples here, two separate questions. If a diameter is 3.3 meters, what would the circumference be? And then what would the circumference be if I had a radius of 4 meters was the second question. So notice how I always substitute in the equation and then I get an answer. So I don't write the answer right away. I'm always going to do the substitution first. What you also might notice is sometimes you'll see these answers which are more exact as 8 pi meters as a circumference, but all that means is 8 times the approximation of pi, 3.14. So 8 pi is actually more accurate than 25.1. Okay, so that's this first slide. The second example kind of moved away from circumference, which is that distance around the circle, to the area that the circle has. So the area formula is pi r squared, and so once we know the radius, we can square it, multiply by pi, and we can know what the area is. The question, though, in example 2 here, is sometimes I put the circle on a coordinate grid. So we had a center of -2 and 1, and then a point on the circle is 1 and 1. And so we can measure this distance here, and that was like 3 units. So our radius was 3 units. So when we substitute it into the equation, we put in 3 units for the radius. And notice how it's 3 times 3, which is 9. But then, I didn't say it in class, but I'll tell you right now that area is a square unit. So that's why we could say units squared. But since it's on the coordinate grid, we don't necessarily have a unit to associate with it. The last question was this kind of Ferris wheel question, where basically, we take a circle, right, and we kind of describe a situation. It's like a story problem. So we have a Ferris wheel, has a diameter of 56 feet, makes 15 revolutions per ride. And all that means is in one ride, you're going to go around 15 times, okay? So if we find the circumference, which is 56 times pi, or 56 feet times pi, well, that's the distance you travel in one revolution. But if we want to figure that out 15 times over for one ride, we multiply that number by 15, and then we get 840 pi feet, or the kind of approximate answer here of 2,638.9 feet. So that was a lesson today, and you can see the homework on the homework page later. All right, talk to you later.